Greetings, Earthlings. Well, my internet is down at the moment, so I guess I have some time to make a brief update video here on the repair of this chubby HP, what is it? HP 34703A, yeah. So, as you recall, we found one of these diodes bad. Now, those original diodes are FD3369. What? FD3369, 100 milliamps, 180 working volts. Can't find those, but I got some 1N645s to replace it. Those are 235 volts, 400 milliamps. So those are more robust. They should make a reasonable replacement. I also, turning this around here, we had a couple of problems on the front panel here, right? One binding post, the knob, if you want to call that a knob, is missing. Couldn't find the assembly available, but I found a post, which is a proper HP binding post, not an exact replacement, but I think I can make it work. Yeah, the threads are a little shorter on the replacement than on the original, but again, I think I can make that work. Replace that, get that back to looking proper. And the other thing is these, whatever you want to call these, collets. They're all bad, all four of them. Cracked and pieces missing and stuff. You can see pieces missing there, maybe. I found some, they're not the right color, but they're proper HP parts. So if I replace all of them, I think it won't look too bad. It'll look like, come on. Anyway, it'll look like that. Okay. A little contrast there. It won't look original, but it'll look, I think that'll look decent enough. Oops, let's see. There. Right? Okay. Finally, my suspicion, of course, is that I've been calling this a hybrid. I don't know. It's a custom analog integrated circuit from HP. It has some JFETs on it, about 7 of them maybe. I don't know the complete pinouts because it's got 22 pins, and some of them are not, at least I haven't found them on the data sheet. All right, let's put that on hold for a second. There are actually 10 JFETs, which are labeled U7A through U7J on the schematic. I've scanned the relevant portions of the schematic so you can see them here, and I think now that I have accounted for all of the pins. So the first scan shows U7A, B, C, and D, and those are on the left side of the schematic here. And you can see that in all cases, pin 13 is common. We'll call that the source. And they're used to switch different voltages, different signals through. And if you look at TP1, you can see it comes in from the input through K7, through a 100K resistor, and then really to those 4 JFETs and the input protection circuit. So it seems like the most likely situation, since we've already checked the input protection circuit, is that the minus 4 volts or whatever it is coming through one of those switches somehow. Looking at the other half of the schematic, we have U7E over there on the left again, but U7F, G, H, I, and J. We also see here RA, RB, RC, D, and E, which I believe are on that, are part of U7 as well. And so, for instance, you can see that zooming in on U7F here, pin 6 is the gate. The source is common to all of them, and that appears to be pin 21. Then the drain of U7F goes through RD to pin 7, and I believe that's U7 pin 7, and then through another resistor, a 1 ohm resistor on pin 7 to I, which connects it to, that's just a common point. That's not, it looks like a ground symbol, but it's not. Or maybe that's a 1, not an I. But we can see if we move over to U7J that there's 2 other I or 1 connections there. Yeah, I guess that's a 1 because we have 2 and 3 also on here. So I think that looking at this and accounting for those resistors really does account for all of the pins of U7. So in theory, U7 could be recreated with, say, surface mount parts on a printed circuit board. The thing about those resistors, of course, is those are going to be critical. I'm not so sure that the exact value of the resistors is critical, but the ratio is probably critical. Ideally, they're perfect resistors, of course, and you don't even have to worry about that. But as I mentioned previously, I'd like to lift the leg. I've got minus, what is it? Minus 6 volts or something, minus 4 volts at a point that should be ground, and the only thing really that connects to is, well, it comes from the input and then connects to at least 4 of these switching JFETs. So what I'd like to do is lift the legs of those JFETs. It's soldered in. It's not real convenient to try to lift the legs. So what I was thinking is I could socket it with some pins. See, I have these nice machine pins. Unfortunately, I don't have enough of them, so that will have to wait. But if I can desolder it and not destroy it in the process, and, of course, I think it may already be at least partially destroyed, but desolder it, solder some socket pins in there, header pins, whatever you want to call these. Then I can plug it back in, but I can bend those leads up that I want to, for the legs that I want to lift. I bend them out, and I can test it that way. It's also possible then that because this part is going to be real hard to track down if I need one, that I could put some JFETs in there, maybe J112s or something, to replace any of them that are bad, and having the socket in place will help that. So let me get these installed, and we'll see if maybe by some miracle they fix the problem, and if not, we'll proceed from there. All right, so here we are. Gonna just have a look at the diodes that I replaced. I think one of them was good and one of them was bad. There's the old diode. I'm trying to find a place to set it. Okay. There. Okay. Well, that's not a great place to set it, but let's see. Okay, that looks like a diode. And if I reverse the polarity, I'm just gonna, set it on that. I said there. Okay. How's that? Okay, good. Reverse the polarity, and that looks like an open circuit. So that diode was good to some level of goodness. And then this is the other one. And I'm not even going to worry about what direction I'm hooking it up, because we're going to try both. So, yeah. Got nothing. Oh, wait. No, look. That looks like, well, I call that a resistor. Okay? but a very low resistor in that direction. Like a short circuit, kind of low-ish. It's not quite a short circuit, is it? And we'll go in this direction. And that also looks like a resistor. Okay. Yeah. Okay. So, yeah, that diode was bad. So let's see if that made any difference. All right, and here it is. I've got it set on volts. I've got a shorting bar across the input, so it's getting 0 volts in. Let's see what happens. Nope, same old problem. Yeah. And yeah. Same problem no matter what. All right. Let me check. I'll just check the test points just to have a look. Okay. So power on. This will be ground. Here's test point. Ooh, there's test point 2. And that's at minus 12 volts. Test point 1 is right here, and it's at, minus 3.9. Okay. Same problem. So now I need to work on the hybrid, or whatever you want to call it, a custom IC, and see if that's the source of the problem. Which seems likely at this point.